Hey engineers, welcome to a hands-on tour of PyFlue. PyFlue is the agent harness framework for Python, built by the team behind SuperAgentic AI. Think of it as Python's answer to JavaScript's Flu framework, designed for teams who want a structured runtime instead of stitching together loose primitives. Over the next 30 slides, we'll go from zero to shipping a real agent. Grab a coffee and let's get into it. So what exactly is PyFlue? First, PyFlue is a harness, not a primitive. It bundles model, tools, state, and sandbox into one runtime, so you don't reinvent that wheel. Second, your workflows live in Markdown skills, right next to your code, version-controlled like any other source file. Third, every result is a Pydantic-typed object, so flaky JSON never ruins your day. And fourth, the default backend is DeepAgents, with a stable PyFlue API layered on top so you can swap engines later without rewriting your app. Now you might be wondering how PyFlue stacks up against the agent frameworks you already know. Crew AI is fantastic when you need multi-agent crews coordinating on a job. PyFlue stays single-agent first, with clean Markdown skills instead of role-playing teams. LangGraph models an agent as a graph state machine, which is incredibly powerful, but also a lot of ceremony. PyFlue takes the simpler harness approach with linear sessions plus reusable skills. Autogen is conversation-heavy, with agents chatting back and forth. PyFlue keeps it function call clean, with typed Pydantic outputs and a sandbox-first security model. And the kicker, PyFlue is deployment-ready Python from day one. Pydantic everywhere, and you can swap backends later without rewriting your app code. Why bother with a harness at all? Honestly, 3 reasons. First, you skip about 3 days of glue code wiring sessions, sandboxes, and tool plumbing. Second, the same defaults scale cleanly from a weekend prototype to a production service. Third, the safety rails are on by default. Writes are off, shell is off, and secrets stay out of prompts. And as a bonus, you can swap the harness backend later without rewriting a single line of agent code. Installing PyFlue is delightfully boring, which is exactly what you want. The fastest path is add PyFlue, which wires it into your project in a couple of seconds. If you prefer the classic route, pip install PyFlue works just fine. The optional extras are where it gets fun. Pull in Monty for safe in-process Python execution, or Sandboxes if you want remote runtimes like E2B and Modal. One small heads up, PyFlue requires Python 3.11 or newer because DeepAgents under the hood demands it. Once installed, the init command does the heavy lifting. Running PyFlue init myagent generates a complete project layout in one shot. You get agents.md, pyflue.toml, and the skill folders pre-created so you can stop thinking about structure. There's even a starter triage skill in the box, so you have something real to read and tweak. And yes, a default file-based agent route is wired up too, ready for webhooks the moment you start the dev server. Let's walk through the layout. Agents.md is your global instructions file, much like a Claude.md. It shapes how every agent in this project behaves. The pyflue.toml file is the configuration source of truth, holding model, sandbox, and policy defaults. Inside the .agents folder, you'll find skills and roles as plain Markdown files you can edit in any text editor. And under agent/default.py, that Python file becomes a webhook route automatically. Nothing extra to register. Now let's run the thing. The simplest invocation is pyflue run -- prompt, which fires off a single turn against your default model. If you want continuity across calls, add the --session flag with an identifier like issue123. PyFlue resumes the same SQLite-backed history. Pass -- stream to watch normalized events live in your terminal, which is great for debugging. And when you actually want the agent to touch your file system or run commands, you opt in explicitly with allow write or allow shell. The defaults are intentionally locked down. Under the hood, PyFlue follows a clean 5-step recipe every single turn. Step 1. It loads instructions from agents.md and claude.md. Step 2. It loads your Markdown skills from the .agents/skills directory. Step 3. It opens or resumes a session by its identifier, so memory just works. Step 4. It routes the prompt through the chosen harness backend, which by default is DeepAgents. And Step 5, it persists results back into the session log, so the next call picks up exactly where you left off. Sessions are how PyFlue gives your agent persistent memory. Under the hood, history is SQLite-backed and stored under .pyflue/sessions, so it survives process restarts. Each session has a stable identifier. Pass the same string twice, and PyFlue resumes the same conversation, no extra plumbing needed. Every turn stores the user, assistant, and tool messages together, so replaying state is dead simple, and when you spin up a child task, it shares the parent's sandbox but keeps its own conversation log, which is perfect for focused subroutines. Skills are PyFlue's secret sauce. Each skill is just a Markdown file. The YAML front matter declares the input and output schemas, so the framework knows what your skill expects and returns. The Markdown body holds the role and instructions in plain English, exactly the way you'd brief a human teammate. PyFlue auto-discovers every .md file under .agents/skills, so adding a new workflow is as easy as creating a file. And from Python, you call them with session.skill, passing args and an optional Pydantic result model. Let me show you what a skill call actually looks like in code. We open with awaitSession.skill, naming the workflow we want to invoke. The string triage maps directly to a Markdown file at .agents/skills/triage.md. That name resolution is the only convention. The args dictionary becomes the prompt context, so the model sees the issue number we passed in. And result equals triage. Result validates the JSON response with Pydantic, returning a real typed object. 4 lines, full workflow. Roles let you scope an agent's behavior without rewriting prompts. You define personas under the .agents/roles directory, each as a small Markdown file with a name and a short instruction body. To use one, just pass role equals when you call prompt, skill, or task. So you might use a coder role for careful, surgical patches and an analyst role for exploratory data work. The neat trick is you can stay in the same session and switch brains on demand, which keeps context but changes tone. Tasks are how PyFlue handles focused subroutines without polluting your parent conversation. Calling session.task spawns a child with its own conversation history, isolated from the parent. The child shares the parent's Sandbox files, so any work it does on disk is visible upstream. The big win is that it keeps the parent log clean of intermediate steps, which matters when you're debugging or auditing later. It's perfect for focused subroutines like running tests, fetching data, or summarizing logs before reporting back. Typed outputs are honestly one of the best parts of PyFlue. You pass result equals your Pydantic model into prompt or skill, and that's it. No manual parsing. Behind the scenes, PyFlue wraps the model's response between result_start and result_end delimiters, then extracts the JSON between them. If the JSON is malformed, an automatic repair loop kicks in and asks the model to fix it. The typed retrieve setting defaults to 3 attempts and is configurable in pyflue.toml, so you can tighten or loosen it per project. Here's typed outputs in practice. The triage result class extends base model and declares 2 fields with default values. When we call session.prompt and pass result equals triage result, PyFlue switches on typed mode behind the scenes, and the value we get back has result.severity as a real Python string, fully typed, autocomplete in your editor, and no manual JSON parsing anywhere. Now let's talk about backends. PyFlue ships with a registry, so you're not locked into one engine forever. The DeepAgents backend is the implemented default, and it covers 99% of use cases out of the box. The OpenAI agents, Google ADK, and Pydantic-typed entries are extension points right now, with their dependencies pinned and a runtime ready to be plugged in. If you have a private harness, register harness wires in your own custom backend in a few lines. The point is, the session API stays identical regardless of which engine runs underneath. The virtual sandbox is PyFlue's safe workspace boundary. It's zero config. You don't have to set anything up. Every session gets one for free. The files live under .pyflue/sandboxes/session ID, so each session is isolated on disk. Path boundary checks reject any attempt to read or write outside the sandbox route. So even if your model goes rogue and asks for ... etc/pass.we, it gets a clean error, and reopening the same session reuses the same files, which means your agent's workspace persists naturally across runs. The Sandbox gives your agent 6 tools, and that's it. The Read File tool pulls files or lists directories. The Write File tool persists text to a path when writes are enabled. The Edit File tool does precise text replacement, no fuzzy regex tricks. The grep tool runs regex search across files, just like you'd expect. The glob tool finds files by pattern, perfect for crawling a repo. And the shell tool runs commands behind a policy gate, only when you've explicitly opened that gate. PyFlue's permission gates start locked. Reads are always on by default. Every agent needs to look around to be useful, and reading is low risk. Writes require allowWrite equals true, with no exceptions and no sneaky workarounds. Shell access needs allowShell equals true before a single command runs, so models can't accidentally rm-ref your home directory. And when an agent tries to do something it isn't allowed to, permission error is the friendly bouncer at the door. Clear, fast, and impossible to bypass. Permissions live entirely inside the init call. No scattered configuration. The init function is the single configuration entry point. Every knob is a keyword argument, easy to read at a glance. Setting allowWrite equals true and allowShell equals true opens the gates the agent needs to do real work. And the allowed commands list narrows shell access to just Git and PyTest, so even a misbehaving model cannot reach for apt install. Even with shell enabled, you have 2 more knobs for safety. The allowed commands list narrows shell access to a known set, say just Git and PyTest, so the model can't surprise you with apt install. Compound shell syntax is blocked by default, which is the default you almost always want. That means pipes, redirects, double ampersands, and command substitution all stop right at the gate. If you trust your workflow, allow compound commands equals. True opens that gate up, and chained pipelines start working again, useful for scripting, careful in production. Secrets in PyFlue are grant-based, not ambient. Anything you pass via env is treated as confidential and never leaks into the prompt. Crucially, the virtual sandbox does not auto-mount those secrets. The agent has to ask for them explicitly. When you actually need a token in a shell call, you pass secrets equals a list with the name, like GitHub, token, on that one specific call. The result is minimum exposure, maximum compliance vibes. Your security team will literally hug you for this. When the virtual sandbox isn't enough, PyFlue offers 4 remote providers. Daytona gives you full Linux dev environments with persistent state, ideal for long-lived agents. E2B is your go-to for ephemeral cloud sandboxes spun up on demand and torn down when you're done. Modal is for serverless container workloads, perfect when you want compute that scales to 0. And Runloop is for replayable agent runs, which is incredibly handy for debugging or building eval harnesses. The beautiful thing is, the PyFlue session API stays identical regardless of provider, pure swap and go. Monty is PyFlue's optional Python execution backend, and it's a hidden gem. It runs agent-generated Python in process with no sub-process, no Docker, just safely sandboxed Python. You feed in host data through the inputs argument, and you can hand the agent helper callables through external functions when it needs to talk to your code. Validate any return value with result equals your Pydantic model, and you get typed values back automatically. And for stateful workflows, dump Python state and load Python state let you checkpoint the repl state between calls. Here's Monty in 5 lines of Python. Setting Python backend equals Monty in init enables in-process Python execution, no sub-process required. The inputs argument injects host data into the snippet. Items becomes a real list inside the sandbox without any serialization dance, and result.result holds the typed return value, ready to use, no string parsing needed. Streaming in PyFlue gives you a live feed of what the agent is doing. Calling session.stream yields normalized events as the agent runs, one at a time, in async iteration. From the CLI, PyFlue run with the --stream flag prints those events straight to your terminal, perfect for debugging without writing any code. There's also a server-sent events endpoint that exposes the same stream over HTTP, so your front end can subscribe directly. And it's great for building live UIs and real-time progress bars where you want users to see the model thinking. File-based agent routes are how PyFlue turns Python files into HTTP endpoints. You drop a .py file in the agents folder, and PyFlue publishes it as an endpoint automatically. Each file becomes post/agents/name/agent ID. No rotor, no decorators. The default async function inside that file receives a context object that gives you everything you need to bootstrap an agent. And on that context, the payload attribute is the JSON the caller posted, so wiring up a webhook takes about 4 lines of code total. Triggers tell PyFlue how an agent file wants to be invoked. Setting triggers equals webhook. True is the default for any route. You literally don't have to write it. The framework assumes it. To support cron-style scheduling, you add a schedule cron string in that same trigger's dict, intended for your own scheduler to consume. Important nuance. The built-in dev server only exposes webhook routes. It deliberately doesn't run cron. The schedule metadata is published for discovery, not execution, so your platform layer can wire it up however it likes. Let's look at 4 real-world patterns. First up, the coding agent. You init with allow_write and allow_shell both on. Coding requires both. Critically, you set allowed commands to git and pytest only, which keeps the blast radius small if the model misbehaves. The setup phase clones the repo into the sandbox before prompting, so the agent has a proper workspace. And you return a coding result Pydantic model with fields like files are changed and tests run, giving you a structured audit trail every time. And here's a complete coding agent in 20 lines of Python. The coding result Pydantic class shapes what the agent returns, a summary string plus a list of files changed. The init call opens write and shell with a tight allowlist of just git and pytest, so the agent can clone, patch, and verify safely. And session.skill_patch runs the workflow, with the issue number passed through args. Run it, and you have a typed result you can pipe straight into your CI dashboard. Next, the issue triage agent. The trick here is using the issue number as the session identifier, so rerunning on the same issue resumes any prior context naturally. You call a triage skill from a Markdown file, passing the issue title and body in the args dict. The skill returns a triage result Pydantic model with fields like severity and suggested labels, which you can pipe straight into your bug tracker. And one of my favorite parts, there's no shell, no writes, just read-only is plenty for this kind of workflow. Now for the data analyst agent. You enable Python backend equals Monty when calling init, which switches on Monty for in-process compute. The agent uses write file to land the CSV inside the sandbox, so it lives in a known location. Then run now Python aggregates rows safely with no subprocess, no Docker, just sandboxed Python execution. The final shape is an analysis result Pydantic model with a metrics dict and a recommendations list, ready to drop into a dashboard or a Slack message. Last pattern, the support agent. You start by using write file to seed knowledge articles into the sandbox, treating it like a per-session content store. Then grep finds the relevant snippets fast, way faster than a vector DB for small corpora. The agent returns a support answer Pydantic model with a cited articles array, so you have receipts when the customer asks how you got the answer. And by reusing the same session per customer, you get context continuity for free across follow-up questions. Time to ship it. The build command is your friend here. Running PyFlue build target Docker writes a Docker file and an app.py file ready for any container platform. For PyES shops, the Railway, Render, Fly, Vercel, and Netlify targets all have first-class deployment artifacts generated for you. CI lovers will appreciate that GitHub Actions and GitLab CI generate CI workflows directly, no copy-pasting from a tutorial. The PyFlue deploy command invokes the provider's CLI when installed and authenticated, so you can ship from your terminal in one shot. And of course, that same Docker image runs unchanged on Kubernetes, ECS, or your own box. And that's PyFlue in 30 slides. You now know how to install it, scaffold a project, write Markdown skills, manage sessions, drive the sandbox safely, plug in remote runtimes, and ship to production. The docs at pyflue.ai go deeper if you want to keep exploring. If this video helped you, hit subscribe and let me know what you build. Thanks for watching. This was Omar Hosni. See you in the next one.